Hello, everybody, and welcome to today's lesson on triangles. This fancy little shape right here. Um, Before we really get into talking about triangles, though, let's talk about a couple of vocabulary words that are the same no matter what type of shape you're talking. First and foremost, our fancy word is vertex. That is when we are talking a singular one of something, one of this, or vertices is both of these. So vertex or vertices are the corners of a triangle. So if we were to look at this and count, we have one, two, three corners. So a triangle is going to have three corners or vertices. And then edges or side. Well, okay, rewind. Um, the corners are typically named with letters. So we might say that this is triangle ABC, meaning that one of these is an A, one of them is a B, and one of them is a C. So we would have corner A, corner B, and corner C. All together, they make, and this is just using the shapes, triangle A, B, C. Okay, so we've got three corners make up this triangle. Those three corners then produce three edges or sides, and those are going to be the lines that connect the edges or the lines that connect the corners. Okay, so if you look now, these are going to be represented by the two letters that make up the line. So we have A, B. So we have edge A and edge B. And to show that we are talking about the line segment that connects those, we're going to put the line over top of it. So there's AB. We'll have AC because we have a line segment that connects those two vertices. And then we have line segment BC. So again, we're just going to say BC. So we have three vertices, vertex A, vertex B, and vertex C, and then three edges, line segment AB, line segment AC, and line segment BC, making that shape of a triangle. So what do we know about a triangle then? What are some things that define, like what is it that makes a triangle? Well, most importantly, it's that word try. Show me on your fingers. What does try mean? Three, okay? Because there are three vertices. Okay, take my time a little bit. There's three vertices and there are three edges. We'll get a little bit more a little later into some more specifics about the angles of a triangle. But just know up front, and like I said, we'll talk about this a little bit more later, um, all of the angles of the triangle will add up to 180 degrees. So on, say, an equilateral triangle, which this one is here, meaning all three sides are equal, all three angles are going to be equal as well. So each of them is 60 degrees because 60 plus 60 is 120 plus another 60 gives us the 180. So those are kind of the three specifications that will make up a triangle. It is a closed shape, which means all of the edges connect. It has three vertices, three edges, and those angles are going to add up to 180 degrees. So let's get a little bit more specific now. Um, to do that, we need to review angles. If you remember, we had three kinds of angles that we talked about. That's just a, happenstance. It's not related at all, just a coincidence. But we had angles that were big. We had angles that were small. So this big angle, this small angle, and then we have angles that I'm going to do my best to draw that make a perfect corner. Just pretend that's the perfect corner. Okay, so we had these three types of angles. Do you remember what these are called? The big one is obtuse. The little one is acute. It's a cute little angle. And then if you remember this one here, where it is exactly halfway between big and small, being a 90-degree angle, we refer to that as a right angle. Okay, you need to remember those three words. Obtuse, say it. Acute, your turn, say it. And right, say it. Acute, obtuse, and right. Okay, we need to remember those three words when it comes to naming our triangles. So we know that all three of these are triangles. This is a triangle. It has three sides. This has three edges, three vertices, three edges, three vertices, three edges, three vertices. So we know that all three of those are triangles. Okay, but are they acute, right, or obtuse? And to know that, you just need to pay attention to the angles. Okay, now this right here, let's see, let me use a different color than white so you can more specifically see where I'm talking. Now this angle right here is acute, and this angle right here is acute. Okay, but don't let that confuse you because it does have this one big one up here. And as long as it has that one big angle, as long as it has that one obtuse angle, then that is considered an obtuse triangle. Okay? Now, if you notice with this one here, all three of these angles are going to be less than that 90-degree mark. Okay? All three of those are less than that 90-degree mark. And if all three of them are less than that, if all three angles are acute, then that's an acute angle. I'm just going to that's obtuse. And then remember the right angle is that exact box. So if it has that exact box, then that's a right triangle. So we would say then, bring my three triangles back. Okay. We would say that this is an acute triangle. This is a right triangle, and this is an obtuse triangle. Those are the three types of triangles that we're going to worry about for now. There are more that you'll learn about later in life, but as far as we're concerned right now, acute, right, and obtuse triangles, all named based on those angles. If there's a square angle, then it's right. If there is at least if there is even one, and there will only be one, we'll talk about that in a minute. But if there's one big angle, then it's obtuse. And if they're all less than that 90 degrees, then it's an acute triangle. So measures of angles. This is where we're getting more specifically into, let's see, let's use a few examples. And we're going to lock so that I can just easily delete stuff later. Okay, so let's just draw a triangle. All right. And I'm just going to estimate angles here because I just kind of drew that. But we have, let's say this one is 120 degrees. And then if we were to assume that these two are equal, which I am just for funsies because I know they are, they're going to be 30 and 30. And the reason I know this is because, as I said earlier, all three angles of a triangle have to add up to 180 degrees. So if I've got 120, that's a 0, 3, 6, 7, 8, and then you bring down the 1. Okay, so we have to remember that all three angles of a triangle are going to equal that 180 degrees. Now, Okay, let's look at a different one. If we take an acute triangle. Okay, so let's say we've got that. And maybe this angle right here is 30 degrees. Okay. And then maybe, so then I need to figure out if these two are exactly the same, how much they are. Well, if it has to be 180, 180 minus the 30 gives me 150. And then we just need to divide that by 2. And I happen to know that 150 divided by 2 is 75. So each of those angles would be 75-degree angles. Okay. The one thing, well, let's see, one more thing I wanted to talk about um, is if we look at this. This is a right triangle. And this is going to be a question on your assignment, so make sure you're listening. If I have a right triangle here, is it possible for a triangle to have two right angles? Think about that. If a right angle is 90 degrees, another right angle would be 90 degrees. How much is that? Okay, 9 and 9 is 18. So 90 and 90 is 180. But how many angles is that? That's two angles. Okay? If I add a third angle into that, no matter what it is, it's no longer going to be 180 degrees. So it is not possible to have two 90-degree angles, nor is it possible to have two angles that are bigger than 90 degrees, because it's just going to equal more than the 180, and every triangle has to equal that 180 degrees. Okay, it is possible, and I'm just going to have to draw this by hand because the software doesn't do it. Every triangle I'd been drawing with the software, if you noticed, like they draw them so that at least these bottom two angles, no matter what size I draw, they're exactly the same. Like I can't make that different. So if I'm going to do this in such a way, it is possible to have a triangle where okay, where maybe this one, let's say, is 130 degrees, and maybe this one is 25 degrees. Okay, so if I have 130 and 25, what's left over there? Well, 180 minus 130. Oh, wait, no, I did that bad. We're gonna rewind. We'll say 30 degrees, because I happen to accidentally randomly choose the. Okay, so if we take that 130 and we subtract that from 180, that leaves me 50. And if I subtract the 30 from the 50, that leaves me 20. So this last angle over here would be 20 degrees. Okay, just keep that in mind. Every triangle will equal 180 degrees, no matter the measurement. Otherwise, it is not physically possible for it to be a triangle. We're running out of time here, so I'm just going to quickly buzz through these. Um, we have acute, obtuse, and right. Now remember, for right triangles, you're specifically looking for the corner. So if it has that right corner, then that's a right triangle. If it has the right corner, that's a right triangle. For the obtuse, we are looking for one angle that is larger than 90 degrees. So here, that one is larger, and that one is larger. So those would be obtuse. And then the ones where they're all less than the 90 degrees are acute. Okay, so just quick review. Triangles are going to have three vertices. They're going to have three edges. Their angles are going to equal 180 degrees. And then based on those angles, you will name the triangle either acute, obtuse, or right. head on to the worksheet. If you still have questions, rewatch or let me know.